Good morning, dear virtual attendees. The subject of my presentation this morning is on water, which is very dear to me and is essential for our well-being and also for our future sustainability. The topic of my presentation this morning is on water quality, environmental factors, and their impact. I would like to highlight how we collectively can quantify water quality and make it a universal standard. My focus today is for drinking water, although the same methodology is true for other applications such as industry and agriculture. By way of introduction, I'm Vaseashta from the United States with affiliations in Washington, D.C., New Jersey, Moldova, Turkey, Romania, and Latvia. Before I start, I would like to thank the chairs for organizing this meeting despite of challenging circumstances which all of us are facing today due to COVID-19, and also for their kind invitation for this lecture. The slide also shows my current location, where I wanted to be, where I am, and the reason for our virtual conference. I'm sure there'll be other opportunities to visit beautiful Morocco. This slide shows outline of my presentation, since this is quite a bit of material, including some photographs. I may have to go through some slides a little bit faster to keep my time. This is a slide which I had presented roughly about 30 years ago, indicating top 10 global priorities. And it's interesting that those global priorities are still priorities as of today, more specifically for number 2, which is water, which is what we are discussing today, and also number 7, disease surveillance and propagation, as you know, because of COVID-19 situation at the present time. And it is for that reason we are in the process of organizing a meeting on global priorities, where we are going to do global, such as the vertical and the regional priorities. And this task force would then make recommendation to different governments for funding to cope with different challenges which come with these priorities. As stated earlier, water is essential for our survival, since pretty much all of our physiological function depend on the presence of water, including homeostasis, metabolism, taste, and even breathing. Unfortunately, over a period of time, the society has not been as careful as it should be in discharging these contaminants. In the next 3 or 4 slides, I'm going to show you some of the picture of the environmental degradation, starting with the Aral Sea at the border of Uzbekistan and Kazakhstan, which shows site of the chemical agent discharge and its impact on the environment over a period of time. This picture comes from Armenia, a city called Kapan, and there are lots of abundant mines which leak into the river, and of course they feed agriculture, and also the same water is used for domestic use. As you could see, the water obviously is highly contaminated, and of course it has negative impact on the human health. This picture comes from Charleston, West Virginia, and as you could see, it's a beautiful city, beautiful town, but nonetheless there are lots of companies. They discharge raw sewage into the Kanawha River, and that's what feeds into the water treatment plants, and of course back to the our drinking water taps. Plastics, especially microplastic, as you know, is a major issue, especially these days. I have several pictures, but this is one of the scene which simply indicates the global problem with the microplastics and how we are going to, as scientists, we need to look into this problem as well. And of course, it has lots of adverse impact on the water quality. Additionally, now the water contains lots of returned pharmaceuticals, such as the antibiotics and the estrogen, which obviously have negative impact on human health, especially if it's not taken without a prescription, of course. More specifically, our filtration systems, they are not capable of efficiently filtering these types of pharmaceutical product. So obviously, it indicates that there is a major issue with those types of contaminants. This slide shows water stress and water scarcity as a function of time. And as you could see, there are several regions which have tremendous water stress and, of course, water scarcity as well. And, of course, this requires further attention to this subject. Interestingly enough, if you see on the right side from 1990 to 2050, not only the water would be stressed more, but also there would be global water scarcity, obviously due to rising population and, of course, due to megacities project on a global basis. This slide shows that one of the projects which was funded for us through NATO because of the fact that water contaminants not only pose human health, but also because of the fact they are open, it poses a safety and security issue as well. So NATO had funded an activity for us to look at the water resources which are readily accessible, and also because of the fact the water controls are remotely accessible, and because of the cybersecurity concerns, water purification systems can be tampered with. So we were asked to look into that as well. I worked for a defense contracting research institute for several years, and I directed two of the institutes, Advanced Sciences Convergence Institute and International Clean Water Institute. International Clean Water Institute was funded by a NATO project, and the Advanced Sciences Convergence was funded by Department of Defense. This is the project which NATO funded for us, and the title for that was Technical Advances to Monitor, Detect, and Remove Contaminants in Water for Safety and Security. And of course, that also shows the affiliation of some of our partners. So this slide shows the mission of the Water Institute, which is to assess, identify, and recommend revolutionary scientific breakthroughs in a multidisciplinary environment using an international partnership network of research scientists to develop next-generation solutions that sense, detect, and also remediate water contaminants. Some of the goals of this project are listed in this slide, which is to include contaminant sensing and detection, and also develop a modality to detect contaminants in real time. The goal is also to investigate ways to remediate such contaminants, and I'll be discussing these goals in the remainder of my presentation. One of the approach which we had followed is known as Advanced Sciences Convergence, which is simply strategic and synergistic activities in a multidisciplinary environment that create a unified system to solve intractable problems. I have worked on several methodologies to develop decision support tools, and perhaps that could be a discussion for a future topic, but I'm going to describe very briefly about the Advanced Sciences Convergence in the following slide. This pictorial representation of the Advanced Sciences Convergence simply shows when multiple fields intersect, they of course create or nucleate different unique pathways to solve scientific and even non-scientific problems and their solutions. This reduces the time it takes to make a specific recommendation, as is shown in this slide by way of evolutionary versus disruptive approach. Based on this methodology, I have made recommendation for defense and security, and now we are using this for water. This obviously creates enhanced data fusion, convergence, and some of the topics in material science and engineering. So the idea is simply to generate data, and based on this data, one can then make relevant recommendation and relevant pathways to solve these types of global problems. I'm going to spend a few minutes on the water quality and to provide some context to the discussion. Water quality refers to chemical, physical, and biological characteristics of water. These are set of standards against which we can assess compliance for local, state, and federal guidelines. Some of the activities impair or impact water quality, and although a lot is done in past 30 years to mitigate, however, due to changing nature of contaminants, we need to ensure that we have universally defined water quality for different application and follow universal guidelines. And of course, as you could see, impact of the water quality in addition to human health obviously is for the pets, wildlife, aquatic life, vegetation, soil, infrastructure, and industry. However, for the sake of this presentation, my focus primarily is on drinking and potable water for its quality, although the same principles apply for different sectors. Having worked in integrated circuit laboratory myself, I know water quality that is used for the production of semiconductors goes through rigorous filtration and testing. Environmental Protection Agency has produced different databases which can be accessed through different websites, and of course these databases are listed in this particular slide. The next 2 to 3 slides are relatively busy, but I simply wanted to show several contaminants such as arsenic, such as asbestos, atrazine, chlorobenzene, and so forth. Several metals are present in the water which we receive at home, such as arsenic, lead, chromium, beryllium, mercury, chlorine, cadmium, selenium, and carbon. In terms of organics, as I mentioned, we have atrazine, we have cyanide, we have glyphosate, hexachlorobenzene, trichloroethylene, and so forth. And most of these are carcinogens, endocrine disruptors, and impact nervous system. Therefore, it's critical that we detect them with accuracy and minimize their presence in the drinking water. The source of this data is from the Environmental Protection Agency, but this is the data sheet which some of us perhaps see, those who receive water from municipality. Of course, my goal is to make sure that we minimize these contaminants which are listed here, and of course create a universal standard globally so that all of us have a high quality of drinking water. Unfortunately, the standards vary from country to country, and drinking water quality standard should be the same worldwide, and that's not the case. And that is one of the focus of my presentation today. So moving on to how nanotechnology and nanomaterials can assist in detection and mitigation of these contaminants. That would be the topic of the following few slides. As we know that nanomaterials have dimension that are comparable to fundamental quantities, this allows us to fabricate sensors with specifications that we need as compared to being limited by the materials. Furthermore, due to its dimensional compatibility, the nanomaterial-based sensors can detect biomolecules, pharmaceutical, viruses, and different types of protein. Enhanced response of these sensors and detector is due to large surface area. And of course, because of large surface area, it has a high surface activation energy. Also, our ability to functionalize specific receptor obviously attract specific material, and it is for that reason we can make sensors which can sense, detect specific metals and specific materials, and also pharmaceutical, as I had mentioned in the previous slide. Most of my laboratory work has been on sensors and detectors, also called by risk characterization. The sensors ranged from detection of chemical, biomaterials, analytes, peptides, radiations, gases, and explosives. But again, in the interest of time, I'm going to only show you a summary slide which indicates that we made different types of sensors. And of course, as the platform, we prepared sensors on chip, network on chip, optical integrated circuit, and system on fibers with great sensitivity, selectivity, and specificity. On the mitigation aspect, we prepared different types of filters using an electrospinning process, and I'm sure most of you are familiar with the process of electrospinning, which is simply putting a different type of polymer and applying electric field, which creates these types of fibers. So with my colleagues in Turkey, we have developed different types of strategies to capture different types of metal, organometallics, and pharmaceutical. This is a slide which simply shows polymeric crygel as potential matrices for removing antibiotics. But nonetheless, we have several experiments in progress which show capturing of different types of metal, organometallics, and pharmaceutical by simply loading different types of material in fiber for different types of application. This simply shows the spectrum of application which are possible by loading different types of materials in fibers made from different polymers. And of course, as you could see, simply by adding different configuration, we can capture we can prepare different types of nanofiber for different application. And of course, one of the topic is not only point of use detection, but also ability to capture this data from remote sites. And for that, we need a cyber-physical system using different types of platform. So we use different types of platform. As all of us know that we live in a highly interconnected world. And this slide simply shows some of the tools, applications, and methodology. This is the methodology which is used for iPhone. And of course, as you know, most of you may have these types of devices to monitor your doors and garage doors and so forth. But we use this for monitoring different types of sensors or different types of contaminants. I wanted to show this slide because I offer a course on cyber-physical systems, having sensors, applications, and feedback loop with a scalability option. This field is growing, and of course, we continue to see many applications. Some of the contents of this coursework are listed in here. This is a multidisciplinary engineering discipline. It integrates the dynamics of the physical processes and the software. And of course, having different capabilities, of course, we could continue to monitor different types of application. This slide simply shows the concept, applications, and challenges of this discipline, and I'm sure we will have another opportunity to expand on this topic and go through the contents of this slide in much more detail. However, integration with nanomaterial and nanotechnology-based sensor offer opportunities in safety, security, and obviously awareness of different contaminants in water to improve quality of life. This is a slide which shows an example which we had prepared as a result of NATO project, which simply shows different sensors kept at different locations, and they all continue to bring data to a central location. So once this data is integrated, of course, this information can be viewed online, and this is what we had used for monitoring contaminants from different locations. Of course, the idea is to continue to add more scientists to this project and see if we could have a global monitoring of contaminant. And once we have that global monitoring, of course, we can then unify water quality. Once we know what types of contaminants are there, of course, we can then begin to put together a water quality, universal water quality guidelines. Again, this slide simply shows unmanned aerial vehicles, which we are also using as sensor platform to capture localized information on a regional basis. These types of systems are equipped with LiDAR. They are also equipped with hyperspectral imaging to provide information in a specified spectral band. Using image analysis, it's easy to identify composition on ground. So we can fly these types of vehicles and capture different information from rivers, lakes, and so forth, and of course, identify the contaminants they have in that area. In addition, these UAVs have other aerial surveillance capabilities where we can capture, as I mentioned, different types of plastic. Wherever there is more plastic debris, we can capture those types of images as well. So based on this capability, the project is also used for other surveillance types of activities, emergency management, and disaster preparedness. But this is simply to show some additional capability, but in the context of water, we are using UAVs to capture contaminants in different cities and towns. This is a slide which I borrowed from Labelium, but our application here is for water quality monitoring for a smart city project, as is shown in this particular slide. Photo is borrowed from Labelium, as I mentioned, and this is used with different types of sensors for this project. So we have used this method for rapid risk assessment tool in conjunction with 3 decision support tools, which we had developed as resulting from advanced sciences convergence, which I highlighted earlier. Lastly, let's briefly talk about the remediation strategies. As I stated, using electrospinning process, we can develop different types of filtration mechanism. And these filters have capability not only to capture different types of metal, but also pharmaceutical and other organic compound. Of course, this is only one, but we can use also 3D printing to make different types of not only filters, but different types of platform to mitigate different types of contaminants for filtration types of application. As you know, 3D printing offered lots of application in addition to water filtration, and of course they are listed in here. But again, the context is for water filtration and mitigation. These were some of the projects which were asked by the Natic Soldier Center to see if we could use our filtration mechanism to prepare filters for these types of application, such as variable kidneys, water desalination, water purification, and so forth. Interestingly enough, nanomaterials exhibit a negative index of refraction with negative permeability and permittivity. This is very unusual. This is very usual for nanophotonics, especially for mitigating viruses and pathogens and mitigating microplastics using nanophotocatalysis. So we have done some experiment using nanophotocatalysis to actually mitigate microplastics. And of course, same application can be used for mitigating different other organic compounds. The experiment is progressing, and I'm sure we'll have more going into the future. So as a conclusion, I have hopefully enhanced awareness of water quality issues and its impact on human health. Also, we need to set standards, not just for drinking water, but also for various other sectors. We can use convergence of sciences approach to use a paradigm shift, including smart and connected systems for more information through interconnected platform. Of course, there are challenges such as funding, finding partnerships, and also intellectual property, and of course, privacy. With that, let me thank all of you for your time. In addition to showing lots of partnership here in this slide, I would like to share some of the key initial partners in this slide. And of course, location close to my home, which is the Washington Dulles International Airport. With that, let me thank you for your attention. Please feel free to forward any questions that you may have for me. Thank you very much, and you have a good day. Goodbye.